Yeah, hi. My name is Hwang. I'm with the product marketing team here at ZI. And today, I'm going to talk about securing your Kubernetes environment. So throughout this session, I'm going to talk about key topics when it comes to securing Kubernetes, as well as some best practices. So keep in mind that Kubernetes security is a very large topic, and I won't be able to cover everything in this particular session. But the goal today is to give a comprehensive introduction to make this topic a little bit more approachable. So when we think about Kubernetes security, it's really not just one thing. It's multifaceted. And typically, you can break down to 3 different sections. First of all, you want to secure container images. If there happens to be a vulnerability within a container image, it makes it to your Kubernetes cluster to runtime. Bad actors can exploit these vulnerabilities and compromise your entire cluster. And secondly, you do want to secure your Kubernetes cluster. Kubernetes itself does have multiple security safeguards in place already. But in order for them to be effective, you have to configure them properly. And there's also some best practice available that can make your Kubernetes cluster even more safe. And we'll be talking some of these best practices today. So finally, if there happens to be a vulnerability that makes it into your Kubernetes cluster, and you have an active attack, how do you go about detecting attack and mitigating those? And we're talking about the different approaches as well as some tools. So when it comes up to securing container images, it's really about scanning them. When you build a container image, you use a base image that could be vulnerable. In addition, when you're building an application, writing code, a lot of times you don't know exactly what's in there. You're importing libraries, and those libraries are importing other libraries, and those can contain vulnerabilities. So it's very important to detect those early on in the software lifecycle. And a good place to start is really during the build stage. You can put this test with building images, and if you have vulnerabilities, provide those feedback to your developers so they're able to mitigate those vulnerabilities. But when it comes to scanning images, it's not a one-time thing. New vulnerabilities detected all the time. So you need to implement container scanning across the entire software lifecycle when deploying to your Kubernetes cluster. So another place to deploy is within the container registry itself. Most container registries nowadays do have built-in image scanning, including OCIR, which is OCI's container registry. But once your container image is running within production, you need something there in place as well. And that's why scanning images within the cluster is also very important. Now, a second aspect about securing container images is really about signing them. And the purpose of that is really to make sure that the container image you get is from the source you're expecting. And the way that container image signing typically works, you have a public and private key. You sign the image with a private key during the development phase for that particular image. And when you deploy it, you distribute that key to the people who are using the image, and they use that to verify the image is from where it came from. So if your container registry happens to be compromised, someone flipped an image that's not the original, using image signing will be able to detect that. And finally, when it comes to images, you want to make them small. And the reason for that, the more tools, the more things you add to container image, there could be potentially more vulnerabilities there. In most cases, the vulnerability will not affect your environment. But just going through the process of looking at the different vulnerabilities, determining how they affect your environment does take time. So best practice is to have minimal images. So when it comes to signing your images, as well as scanning the images, there's actually a lot of tools available out there. So these are some of the more common tools that I've used. So for example, NewVector. NewVector is actually more than the image scanner. It's actually a security platform, but with its scanning capabilities, it can scan images during the build phase. It can scan images within the registry, and it also can scan images during the runtime. So the tool I found that's very simple in terms of signing images is Cosign. And we'll go over both of these tools. So this is what the NewVector console looks like. It's deployed directly into the cluster itself. And with here, I've actually integrated with my container registry. Sorry about that. Let me just log back in. So you'll notice here, and I'm just going to pick a particular image to actually look over. So one thing you'll notice that when using an image scanning tool, it actually scans the images in different layers. So for example, it'll tell you exactly at what point within the Docker file the image is at where the vulnerability is introduced. And this makes it easy for developers because they can locate exactly where the vulnerabilities are and go ahead and mitigate those. So one thing to keep in mind that you always want to use as minimal image as possible. And the reason for example, in this case, you have over 100 vulnerabilities to go through. Even though most of the vulnerabilities will not affect your environment, but just trying to go through every single one, determine what they are, will be very time consuming. So in addition to scanning container registries, NuVector is also to scan your containers in runtime itself. So looking here, every single of these pods are running with the environment, the one with the red dots on them, these are indicating there's a vulnerability within them. So if I go ahead and click on this, you will see what vulnerabilities are in there. And for each of these, it will provide a URL to indicate what those vulnerabilities are and how to go about mitigating them. Okay. So the second tool I want to look at is cosign. And cosign is a very easy way to be able to sign container images. So typically, when you first start signing an image, there's one thing you need, and that is a key pair, basically a certificate key pair. And cosign allows you to generate them pretty easily. So in this case, the command to generate it is basically just cosign. If you look over here, we have a key pair generated for signing. So earlier, I've already actually So previously, I've already uploaded 2 particular images to my registry already. So with now my key pair, I'm able to go ahead and sign of them. And there, my key, I have an image that's actually signed my registry. And this is typically done in the build phase. Now, during the deployment phase, it's time to actually go and verify this particular image. And you can use another cosign command here. And here, so the image is now verified. So I know I'm doing this manually, but typically you would actually integrate in your CI/CD pipeline. So during your build phase, you actually sign the image. And when you actually deploy, you will verify the image with the public key. So now that you have your tools in place in order to secure container images, The next part is really securing the Kubernetes cluster itself. And the place to start is, it's a good place to start is you really at the network layer. So from Kubernetes perspective, all communication between your Kubernetes cluster, the worker node, as well as users, it goes through the Kube API server. So you want to make the Kube server as little accessible as possible. So typically, this would mean using a private endpoint. So let's say you do have a private endpoint. It's only accessible private network. How do you go about accessing it? A good way of using it is using bastion host. A bastion host sits between the public network and the private network. And for users, they need to log into bastion host, and then they're able to access their API server. So you want to put the network perimeter around your Kube API server. And once you have your Kube API server around the network perimeter, you really want to implement RBAC. And the purpose of this is really to make sure that whatever privilege you give to your users, as well as your application, they only have what they need to use. Now, within Kubernetes, this is actually implemented using Kubernetes resources. At the cluster level, that means rights granted for everything within the cluster. That is done with the cluster role. And then you use the cluster role binding and then bind a particular user. So in most cases, you do not want to use the cluster role because that's too permissive in this case. You do want to scope it down to a particular namespace, and that's where we use the role binding. Now, another thing you can do with Kube API server is really implement auditing. That way, for particular users to make a particular change within the Kubernetes cluster, that is actually captured. So if you need to investigate, you can definitely go back to your log if you have the audit server enabled. So network traffic within cluster itself also needs to be managed in this case. You want to make sure that only the servers that need to talk to each other are allowed. By default, within the Kubernetes clusters, all pods in a flat network, which means they can talk to each other, and that can be dangerous because the one pod is compromised, essentially they can access every single pod in your clusters. And there are actually different ways to be able to minimize the access between particular services. As Audrey mentioned previously, we do have network policies. Those are typically implemented using network plugin like Calico. But with network policy, in terms of enforcement, it's done at the IP layer and up to a port number. So in terms of what can enforce, it is a little bit limited. Now, there are other options as well. For one, there is a service mesh. A service mesh is more than just for security, but what you can do is between service, when you communicate between the service, it allows you to go to encrypted, but also using mutual TLS, they can also identify each other first. So a third option is using firewall specifically Kubernetes. And there's actually several of them out there, including some that I'll be showing a little bit later. Okay. So what I'm showing here is a couple things to be able to enforce the traffic I previously talked about. First of all, using Kubernetes, which is a Kubernetes firewall. And by the way, NewVector is open source. And the second tool I'm using is STO. It's a service mesh, a pretty well-known one. So let's go take a look at these. So what I'm showing you here is actually the console screen for NewVector. I have to implement rules in place that only certain services can talk to each other. So in this case, I'm only allowing the ingress to talk to my development server, within it's allowed to talk to my Redis server. Any other communication is actually blocked, which is what I'm showing here. So if we look at the rules in this case, they're all whitelist rules. And what that means is, by default, everything cannot talk to each other. And you have to explicitly define what can communicate each other. In this case, the definition is done from service to service. And the reason for that is because within Kubernetes, all the pods are ephemeral. and they come and go. And when they do come and go, the IP addresses do change. So you want to apply them to service, so if a new pod comes up with a new IP address that belongs to service, those will still apply. So another thing to look at is part of rule definition, it's actually done at the protocol level. So one thing about NuVector, it is a layer 7 firewall. So when it's determined the traffic type, it's actually looking at the protocol itself using deep packet inspection. So when I define these rules, I'm saying anything that HTTP can communicate with particular services, I'm not specifying port. And the reason is because with NuVector and the deep packet inspection, it can determine exactly where the protocols are. So within my cluster itself, I also have an application that's defined using that. I do have an application that has istio. I do have istio installed to protect the traffic. One thing you'll notice that the traffic between between STO services or served as part of STO, they're actually encrypted, which is shown here. In addition, you'll kind of see something that's funny looking thing here, and what it kind of looks like the pod is talking to itself. And the fact is, it is. And the reason for this is because when you're implementing Istio, you're using a sidecar container. And that sidecar container is actually a proxy that, in its purpose, to be able to direct traffic between the different services. Now, as an application container, if I want to talk to another service, I will first send my traffic to my proxy container. It's up to the proxy container to validate the other server exactly who it is, as well as identify itself, and then encrypt the traffic across. But once that traffic makes it to the other pod, it's up to that proxy container to be able to decrypt it and then send it to the application container using the loopback interface. And that's what they're indicating here. So with a service mesh, even though the traffic is encrypted, you can still use it alongside a layer 7 firewall, specifically Kubernetes, to get the best of both worlds. Not only do you have deep packet inspection, but your traffic between services is also encrypted, as well they're able to identify who they are. Okay. So another important aspect of securing a Kubernetes cluster is securing the etcd store. And what the etcd store is basically a key value store that contains all the information for a Kubernetes cluster. Every time you make a change, every time you add a new resource, they're all within etcd store. And the only component that should talk into etcd is the Kube API server. So what you want to do is, first of all, put a firewall between the Kube API server and the etcd. And depending how it's implemented, in most cases, when you have a cluster managed yourself, that is actually a separate cluster outside the Kubernetes itself. So it makes it easy to put a firewall in front of it. If you haven't used a managed Kubernetes service like OKE, well, that's something you don't have to worry about. That's actually taken care of for you. And in addition, with the etcd, you do want to encrypt it. Because if someone do get access to the etcd store, essentially they do have admin access to your entire cluster. Any changes made within your etcd store, well, they're reflecting your cluster. So it's very important to be able to lock it down. And so another point that you need to lock down is the kubelet. So within every single Kubernetes worker node, there is a kubelet process. And by default, the kubelet is not secure on each of the worker nodes. So if someone gains access to your kubelet, essentially they can make modifications to the worker node itself, and they potentially can steal credentials that can affect the rest of your cluster. So it's very important to lock it down. So there are some best practices as part of the CIS. So CIS is basically the Center for Internet Security. And they actually define many standards for different things for security, Kubernetes being one, as well as container Dockers. So there are many things you can do with the kubelet to lock it down. But the good thing is it's not something you have to memorize. There are actually scanners available that will show in a little bit that will actually scan each worker node and tell you how to go about securing them. And finally, within your Kubernetes cluster, you do want to implement security policies. And what security policies is definitions that you provide that make sure that certain things do not, certain type of Kubernetes resources do not enter your clusters. So for example, if you have a deployment that has container or a Kubernetes pod that has too many privileges that could potentially hurt your cluster, you want to make sure it's denied. In addition, there's other things you can do as well. So for example, if you have container images with too much vulnerabilities, well, you can also deny it using security policies. So within Kubernetes, the way the security policy is implemented is using a mission controller. So when you issue a kubectl command to deploy something, essentially the Kubernetes API server will forward it to the mission controller. The mission controller will then run against a security policy, and if something that it should not be there, it will definitely reject it. Okay. So what I'm going to show here is a couple ways. Well, first of all, using CI's benchmark, how can I secure my kubelets? And secondly, I'm going to show you how using the mission controller, I can deny things from entering the Kubernetes cluster that should not be there. So the first one I'm going to show you is kubench. And the kubench can deploy in different ways. It can deploy within a host itself, like Linux, and run against your cluster. But it can also be run at the job within the cluster itself. And that's what I've done here. So if I look at within my cluster, well, first of all, you'll know there's a kubench job that's actually completed here. Now, if I want to look at what's within the scan, I can simply look at the log information here. And what it's showing here is basically all the things that detected within my worker node that could potentially be fixed in this case. So that's one way of doing it. So with new vector, it also has the scanning capability built in place. So if I go look at my nodes in this case, I can eventually scan my nodes. And from here, I can look at compliance. And what it's showing me all the different things we should be concerned with in terms of securing your worker nodes in this case. And for any of these, I can simply click on it, and it'll tell me what the remediation path. And all these recommendations are actually taken from the CS benchmarks. Now, we also talked about the mission controller. So within my cluster itself, it integrates a new vector and mission controller. And let's look at the policy you can create in this case. So what I have here, I've created a couple different policies. First of all, I don't want any pod that actually has the root privileges from being deployed. And secondly, I'm also adding the pod security best practices. So in previous versions of Kubernetes, you have the pod security policies, and that's what you were using back then to be able to control, be able to deny certain type of pod from entering your environment. So now this policy in place, let's take a look what I can do with it. So this is actually a Kubernetes manifest app here. And there's certain things that here that really should not make it to any type of Kubernetes clusters. For one, it's actually running the root user. So that's definitely a no-no. But in addition to that, it actually has a couple additional capabilities as netadmin as well as sysadmin. So netadmin allows a particular pod to be able to make network changes on the host itself. That's something that should be denied. And sysadmin basically allows you to modify the file system within the actual host. So let me go and try to apply this. you'll notice here that this particular deployment has been denied, and it's due to the policy that we actually created to be able to deny this particular this pod with this type of privilege from being deployed. Okay. Okay. So we talked about tools to look to secure containers. We look at tools to be able to secure your Kubernetes cluster. So by the way, this is not all the best practices out there. There's definitely a lot more. But finally, this also takes us to runtime security. So with runtime security, there's different tools out there, and there's also very much different approaches. One of the more popular tools out there is Falco. And the way that Falco works is really look at the system calls. And for those of you who don't know what system calls is, think of it as a protocol. So if you ever take a network trace, you can traffic across. But for this particular protocol system calls, it's really a communication from containers that you deploy within the Kubernetes cluster and the kernel itself. So what Falco does is really monitor these particular system calls, and if it sees anything that can be detrimental to your cluster, it will alert you on it. Now, by default, Falco do have some rules in place, but it also has its own domain-specific language that allows you to capture very granular things. So for example, you can write things that ask granular, I say, okay, if you have a file right into the etc directory with a specific word, Falco is able to capture that. Now, with Falco, there's really no enforcement. It's really more of detection. But it can ship information to another tool that can help with enforcement, but also with the logging and detection as well. So if you're looking for ways to do prevention when it comes to system calls, there are other tools available, things like Seccom and AppArmor. So NuVector kind of takes a very different approach when it comes to detection at runtime. Rather than looking at system calls, it looks at network connections and look at specific processes. You can definitely write rules in place, but with NuVector, it also does what's called the baselining. And the purpose of that is really, we run a particular container. It'll look for all the network connections it has. It'll look for all the processes, and then after you review and say, oh, you know, these are the right things for a container to do, you can lock it down. So afterwards, if there's anything that's outside of what's been defined, it can either trigger alert or it can actually active stop it. So let's take a look at what Falco and NuVector can do in this case. So what I have here is a Kubernetes cluster with a very simple 2 worker nodes. And both of these have Falco installed in them. So Falco can either install as a daemon set, or can be installed directly on the host himself. In this case, I've installed them on the host. Now, let's look at some of the Falco configurations. So these are the rules for Falco. It is its own domain-specific language, and it does have a little bit of learning curve. But the rules I have in place right now come straight out of the box, so there's really no modification there. And there's already some pretty good rules there already. So how do I actually use this to be able to detect activity within my Kubernetes cluster? Well, let's take a look at it. So I do have one pod that actually is installed in this particular cluster. And if I look at it, it's actually deployed in one of these other worker nodes. So in this case, the log information will actually belong on this particular worker node. So I'm going to actually tail what's actually in the syslog. So by default, Falco will put anything it detects within syslog. So now I'm going to access a particular container here. So typically within a running Kubernetes cluster, you would not expect someone to open shell directly in the pod. And that's what I'm doing here. And as you can see, with System Falco, because there's a rule in place, it's actually detecting it and putting within the log itself. So other things that Falco can detect, so for example, within the container, if I'm trying to modify it, you'll notice that Falco is detecting as well. So let's look at how NuVector goes about doing runtime detection. Well, first of all, we talked about earlier about the network itself. So for each of these containers, I can put them in different types of mode. So for example, when I put them in so it's different, they have different stages in this case. So you can put them in learning stage. So during the learning stage, it's really exactly what it's doing. It's basically baseline the container in determining what network connections it needs to have, what processes it have. Now, once you review these rules and you determine these are the right rules to have, then you can lock it down. So anything outside what's defined, the NuVector will be able to either block it, or it can block the process, it can block the network connections, or it can even quarantine the container. And what quarantine basically means is it takes that particular pod, it blocks it from the rest of the network, but it keeps it alive. That way, if you need to do forensic analysis, you can go into that particular pod and look at the different processes running and the different transactions that's happening, so you can get an accurate view of how the attack is taking place. So this concludes my presentation today. Because Kubernetes security is such a big topic, I was able to cover everything, but hopefully this provides you with a comprehensive introduction. So when it comes to Kubernetes security, it becomes a much more approachable topic. Thank you.